Hi, my name is Camila Gonzalez and I'll be your guide for this lab. The purpose of this lab is to neutralize a 250 milliliter solution of a 3-normality H2SO4 acid. A crucial formula for this lab is M1 times V1 equals M2 times V2, or N1 times V1 equals N2 times V2, where M stands for molarity, or N stands for normality, and V stands for volume. The first thing you want to do is to convert molarity to normality, given that you want to have the same number of H's in the acid as the same number of OH's in the base. So to convert from molarity to normality, one must multiply the molarity by the number of OH's in the base, or H's in the acid. In this case, we will multiply by the base, that's NaOH, and it only has one OH. So we will multiply 4 molarity times 1, which will equal 4 normality. Now that you have found the normality for NaOH, which is 4N, you would want to find the volume needed from the sample base NaOH to neutralize the solution of the acid H2SO4. So now you only have to plug into the formula N1 times V1 equals N2 times V2. It is given to you that N1 equals 3N and V1 equals 250 milliliters. So you multiply 3N times 250 milliliters and make it equal to 4N times V2. Now you have 3N times 250 milliliters divided by 4N, where the normalities will cancel out to give you the volume of 187.5 milliliters that is needed from the sample base NaOH. After you have found this, you have to find the molarity of H2SO4 by dividing the normality, which is 3N, of the solution by the number of H's, which in this case is 2, in H2SO4. So 3N divided by 2 is equal to 1.5 molarity. Now, look online for the densities and molar mass of H2O and H2SO4. The molarity for H2O is 18 grams per mole, and the density for H2O is 1 gram per milliliter. The molar mass of H2SO4 is 98 grams per mole, and the density of H2SO4 is 1.8 grams per milliliter. Now, use the molarity formula, which is molarity equals to moles over volumes measured in liters, to find the moles of H2SO4 in the solution. So, use the molarity found, which is 1.5, and make it equal to moles over the volume given, which is 0.25 liters. Now solve for moles by multiplying 1.5 times 0.25, which will equal to 0.375 moles of H2SO4. After that, multiply by H2SO4's molar mass to find the grams present, and then divide by its density to get the volume of the substance present in the solution. So, take the moles you have found, which is 0.375, and multiply it by the molar mass of H2SO4, which is 98 grams per mole, which will equal to 36.75 grams. Then, divide 36.75 grams times 1.8 grams per milliliters, and it will equal to 20.4 milliliters of H2SO4, which is approximately 20 milliliters. After this, subtract the volume of H2SO4 found, which is 20.4 milliliters, from the total volume of the solution to find the volume of water. So, do 250 milliliters minus 20 milliliters of H2SO4, and it will equal to 230 milliliters of H2O. Then multiply this volume of H2O by its density, which is 1 gram per milliliters, and then divide by its molar mass to find the moles of H2O present. So multiply 230 milliliters by 1 grams per milliliters, and it will equal to 230 grams. Now divide 230 grams by 18 grams per mole, and it will equal to 12.7, which is approximately 13 moles of H2O in the solution. Repeat the process done for the acid of H2SO4 for the base NaOH. The density of NaOH is 1.515 grams per milliliter, and the molar mass is 40 grams per mole, which was found by adding its AMU, which was 23 plus 16 plus 1, which equals 40. Now find the moles of NaOH by using the molarity formula, which is 4m equals moles over 0.187 liters. Now multiply 4m times 0.187 liters to find the moles, which is 0.748 moles. Convert the moles to grams by multiplying the moles by NaOH molar mass, which is 0.747 moles times 40 grams per mole, which equals 29.92 grams. Now divide the grams found by NaOH density to find the volume in milliliters. So you take 29.92 grams divided by the density, which is 1.515 grams per milliliter, and it will equal to 19.75 milliliters of NaOH. Now subtract the volume found from the solution. So 187 milliliters, that is from the solution, minus 19.75 milliliters of NaOH equals to 167.25 milliliters of H2O. Multiply the volume of H2O found by its density, which is 1 grams per milliliter, to find the amount of grams. So take 167.25 milliliters of H2O times 1 grams per milliliter, which will equal to 167.25 grams of H2O. Now take the amount of grams found and divide it by its molar mass, which is 18 grams per mole, to find the amount of moles of H2O present. So take 167.25 grams divided by 18 grams per mole, and it will equal to 9.29 moles of H2O. Now that you have found the moles present of the acid, the base, and the water, you have to use these moles to find the ratios in order to draw the microscopic views. So you take the smallest amount of moles, which in this case is 0.375 moles of SO4 to the negative 2 divided by 0.375 moles equals to 1. Divide H, which has 0.75 moles, divided by 375 moles, which equals to 2. And then do the same for H2O, which has 13 moles divided by 0.375 moles, which equals to 35. Now do the same for the base. In this case, the smallest amount of moles is 0.748 moles, so divide 0.748 moles divided by 0.748 moles, which equals to 1 of OH. Now for Na, do 0.748 divided by 0.748, which equals to 1. And then do the same for H2O, which has 9 moles divided by 0.748, which equals to 12. Now that the ratios have been found, we are ready to draw the microscopic views. We're going to start with the original base. Since we found 1 for OH, 1 for Na, and 12 for H2O, we will draw 12 for H2O, 1 for Na, and 1 for OH. In this case, one blue circle with 2 little yellow circles will stand for H2O, and each circle will stand for 3 moles of H2O, so we will only have to draw 4. And we will only have to draw 1 mole of Na and 1 mole of OH. For the microscopic view of the original and strong acid, the little circle with the 2 yellow circles will be representative of 5 moles of H2O. The green circle with 4 little blue circles will be representative of 1 mole of SO4 to a negative 2, and then the red circle with the 3 little green circles will be representative of 1 mole of H3O, the Bronsted base. So we will draw 7 of the H2O, 1 of the SO4, and 1 of the H3O.